Here, page 196, direct proportions. Listen carefully. If you struggled with the proportion problems, which is understandable, especially when it gets tougher, we have to get more practice. And this is a nice, I think it's a little bit nicer because the numbers are going to be, the numbers aren't easy, guys, but it's very direct on what you need to do with your cross multiplication. Okay, we need to get a definition of what a direct proportion is. We did proportions, and now we're talking about a specific one. And I'll actually.
It's a very direct proportion. Like a fraction and then a unit ratio or something like that. Ratio, unit ratio. A fraction ratio.
When one quantity increases, the other quantity. So I had two guesses there. Other quantity increases. So when one increases, the other one increases. And you can also say when one decreases, the other one decreases. So that sounds a lot like something we did last chapter. And raise your hand if you remember when one quantity goes up, the other quantity goes up. That was actually raise your hand with Emma.
Like the graphing.
Okay, yeah. What about the graphing though, Justin? What? Okay, so what specifically about the slope? When one thing goes up, the other thing goes up. Will?
Like if the positive goes up and negative goes down. Like relationship or something?
Yeah, which one is it? When one goes up, the other one goes up?
Yeah, positive.
Positive relationship. So we're still talking about that, but we're not going to graph it. We're going to use proportions to show that. Okay, here's our example. Page 196. Can someone read the first paragraph there? The ocean. Starts with the ocean. Okay, I'll go with Avery. All right, I'll go with
Not me.
Finn.
Okay. The ocean's temperature decreases
Yeah, we'll say that 4 degrees Celsius. Okay, you guys.
For each 100 meter decrease in depth. What would be the temperature drop at 300 meters decrease in depth?
Okay, so it's giving us a scenario. When you go 100 meters down in the ocean, you decrease your temperature by 4 degrees Celsius. Okay, and I know that's hard. We're dealing with Celsius, and we're also dealing with meters, right?
Yes.
So we normally deal with Fahrenheit and like feet, but it's the same idea. So here's what we're gonna put. We're comparing two things. We're comparing temperature and we're comparing it with the depth. So the depth going down or up in the ocean. So when we have two quantities being compared to one another, that forms a ratio. When two things are being compared, temperature and depth in this example, it's a ratio. But the direct proportion comes in this way. All right, 4 degrees Celsius drop for every 100 meters. It says the question, what would be the temperature drop for a 300 meter decrease in depth? Okay, so here's what we're going to set up. We're going to set up a proportion. Now, I told you already, and I'm just trying to reiterate this because I don't want you to be confused. Some of you could do this problem, you already figured it out. Awesome, that's good. But we need to use a proportion so that when the problems get into decimals and fractions, you do the same thing and you still get the right answer. Okay, so here's our proportion set up. What does a proportion always have to have?
An equal sign.
Equal sign and two ratios. It has to have two ratios. Ratio here, ratio there, and they equal one another if it's a true proportion. All right, and these are. All right, what was the first scenario? 4 degrees Celsius. And what was the 100? Yep, okay. So we're talking about temperature in Celsius, and I'll put that up here. And we're talking the depth in meters, because we do need to have units, because if I say it's a 4-degree drop, you're like, oh yeah, 4 degrees Fahrenheit. But what am I talking about? 4 degrees Celsius. Oh, and we went down 100, and you're like, oh, cool, 100 feet maybe? 100 miles. No, 100 meters. Okay. They asked, what would be the temperature drop for a 300 meter decrease? Does anyone know where I would put the 300 meters? Why does it go at the bottom?
Because the chart says the depth.
We're talking about depth. So the depth goes on the bottom. Now, I'm going to give a secret here. Did it have to be temperature over depth? Like, that was the only way to work this problem. No. You could have flipped them as long as you flip all the numbers appropriately. It doesn't matter how you flip, how you write them down like that. Just make sure you're consistent. And I don't know what that temperature change is, so I'm going to figure it out using a proportion. Now, to help your math, you can always reduce a fraction before multiplying cross multiplication style. So does anyone know anything that can simplify? Yes, sir?
4.
And?
100.
Yeah, 4 and 100. 4 goes into 4.
1.
4 goes into 100.
25.
So now I'm not dealing with 4 and 100, I'm dealing with 1 and 25. Makes it easier, right? All right. You should get the same answer if you work it out right. Yep. What's 1 times 300? What's 25 times x?
25x.
All right, how do I figure out what x is? Divide both sides by 25. And then instead of doing 1200 divided by 100, which is not that bad, you can just do 300 divided by 25. And go ahead and work that out. 300 divided by 25. So it has to be like that. It cannot be switched around. Oh, hold on. Save the answer for just a moment. Get your answer. And listen to me. I'm going to make a point out of this lesson that if I put this answer that I'm going to put on the board, it's going to be counted wrong. And if I put what you tell me I should put, it should be counted right. And you're like, what are you talking about? Let's do the math here. Did you guys get?
We didn't put the units.
Okay, hold on. I didn't do anything yet. But 25 goes in that. All right. Is that my answer?
No, you need units.
Please do not put just a number. You need to put units, which would be that.
Wait, how is it meters? It's Celsius. Celsius.
So, does it matter the units? 12 degrees Celsius. You got to put the right units. Yeah, that means degrees.
Well, the units I think are the same.
So, you could, like you said, for every 2 meters, the ship goes 100 meters. So the same units. But normally we'll have 2 different. Yeah, so I think we brought that up. What if you just did 4 times 300?
1,002.
And then divided by 100, you would have gotten that. Or 4 times 3 would have given you 12. But are the numbers always going to be that easy? Yeah, so that's why we do the process. I wish. Man, it'd be so fun if we were just easy problems. Sorry, I see 2 hands. One of them's right here, Paul.
How do you know what unit to use?
That's a great question. What did they call the temperature? 4 degrees. So, and then what did they say? The depth was 100 meters. So you know you're talking about Celsius and meters. And that's how you know. And then were you talking about the temperature or the depth on our missing value? We're talking about temperature goes up top, so we're talking about Celsius. Good question.
Could you do x equals Celsius?
Yeah, you can say x equals totally good Celsius. Yep. Nope, you don't have to, but if you want to clarify, that's totally okay with me. All right, let's do another one.
Is it because it already gives us the D?
Can you what?
Is it, wait.
Okay, that's right. Let's look at example number 1. A car travels 360 miles in 6 hours. At that speed, how long does it take the car to travel 120 miles? So, yeah, and it's there, example number 1. And they give you a little diagram, which I think is good. And actually, guys, that has a practical effect Like even if we're not talking about 6 hours of driving and whatever the answer is going to be, the speed is going to matter on this trip. Okay, what are the two things they're comparing in this problem? Yeah? Oh, sorry, Abby? Okay, miles, so distance. No, and you're good. The distance and time. Yep, they're saying 360 miles in 6 hours is what they said. So what's your unit for distance?
Miles.
Miles. And what's your unit for time?
Hours.
Hours. So I put that because when I get my answer, I got to make sure I put the right unit. If I don't put the right unit, it's wrong. Okay, so what's the first scenario that they gave to me? They said that if a car travels 360 miles in 6 hours. But is this a proportion?
No.
No, because I need another
Ratio.
ratio. Good, ratio. How long does it take for it to travel 120 miles? Where does the 120 go? At the top. At the top. So I don't know what this is, right? And again, guys, I'm looking at your homework. They're not giving you nice numbers. They're not giving you 360. So if you can do these in your head, that's cool. I mean, that does help for some these problems. But on other problems, it's not going to do you any good. So please don't just, Mr. I can just do this in my head. Yeah, congratulations. The examples are done in your head. The homework's not going to be that easy. So here's what we're going to do to make your life easier. Is there anything you can simplify?
Yes.
Okay, Elliot.
6 and 120.
Okay, you could simplify those if the 120 was over here or the 6 was over there. So I don't want to simplify these two.
Oh, you could do 6 and 360.
Yeah, I'm going to simplify this. What does this? 60 over 1. That made the problem much easier. Why? Because,
Smaller numbers.
yeah, what goes into both of these?
Or just simplify.
60? Oh, no, 2.
6 goes into both of them. 6 goes into, 2 does. 2 does. But 6 goes into 6 once. 6 goes into 360 60 times.
Our homework isn't going to be nice like this.
What's 60 times x?
60x.
What's 1 times 120? Awesome. That's not too bad. Divide both sides by 60. And you get x equals 2 hours. And again, if you could do that in your head, that's good. It's not bad. It's not going to be very helpful tonight.
How many questions?
Not too bad. Yeah, what goes on the bottom of each ratio?
Oh, okay.
Time, so hours. So that's how we know it. That's why I write all that down to help me out. All right, last one here, and this is where it starts getting a little trickier. Who can read for me example number 2? Tucker.
A plane flies 1,800 kilometers in 2.5 hours. At that rate, how much farther will the plane travel in another 3.5 hours?
Okay, so they gave me, again, distance and what? Time. Get a, what does hours mean? It means time. And what does kilometers mean? It means distance. So they gave me the distance in kilometers, and they gave me the time in hours. So similar to the last problem. All right, a proportion. A proportion has to have an equal sign and 2 ratios. What's the first ratio? Dylan.
1,800 kilometers and 2.5 hours.
Yeah, so I'll put here 1,800 and 2.5. So I'll put those two together. And then my second ratio, where does that 3.5 go?
Down below.
Yes, Dan? On the bottom of the second one. All right, I'm trying to find this amount. So here, when you have decimals, don't worry about canceling things out because people get that mixed up too much. You're just going to cross multiply. So what's 1,800 times 3.5? Someone figure that out. Help the class out. And then what's 2.5 times x? Thankfully, that's not too bad. All right, so 1800. I'm going to see. I don't know if you guys ever do your multiplication like this. That's how I grew up teaching it or learning it.
14,400.
That's how I do it. How do you do it?
Decimal.
We put it all the way at the end. I do it at the very end. I do it at the very end. I go all right.
Yeah, we do it like we put the bottom number at the very top.
Yeah, that's what I do. Yeah.
Wait, does it matter?
No, it just makes all those zeros go away because I don't like, when you multiply by 0, what do you get? 0, 0, 0, 0. Instead of having all those zeros, I just leave them off at the end.
How'd you do it?
Sorry?
You just added.
Yeah, what happens, listen, I put those zeros off to the side and I did this multiplication, right? And I got 630. That's what I got, 630. But didn't I have those 2 zeros in there? So I put them at the end, and then now I count my decimal place. So it's 1,6,300. I mean, that's what I do. Yeah, I think that's easier, but if you don't like that, I don't care if you don't do it. I'm not offended by that at all.
Oh, I forgot the decimal. That's what I got wrong.
And see, that helps me not to get all my place values all mixed up and all the work drifting off, because that happens. So I get 6,300 equals 2.5x. So what do I do to both sides? Divide by 2.5. And when I was looking at the homework, and I'm going to glance at it again, they're not going to be like repeating decimals. They're going to end, and they're going to end tenths or hundredths at the most. So if you're going to get this work where you're getting decimal and you're just like continue on division, you probably did something wrong. 6,300 divided by 2.5. Anyone know what to do first?
Move the decimal.
I'm going to move it here once and move it here. Oh no, 25 goes in 63. Twice, that's 50. Sorry, Elliot, we're going to have to do long division here. 25 goes into 130. I think it's 5 times, and that's 125. Remainder of 5. So I bring that 0 down twice. No remainder. Bring down that 0.
And there you go.
Yes.
1,500.
This Ray has very big IQ.
I'll tell you. Let me say something. Is that my answer?
No. Miles. Kilometers.
Yeah, kilometers, and that. Sorry. What did you say? Right, I heard you say.
I said you have very big IQ.
I don't. I don't know what it is, but I would say, how I got better at this.
Practice.
And some people might get quicker at practice than I will. I admit that. And some might take a little bit slower, maybe. But it's not that.
Did ninja speak into your brain one night and now you're a math teacher?
No. Took a long time.
want to be a math teacher. Why would you want?
Chloe, I have a question with quiet.
Does it matter if you put like 2.5x equals 6 times 1,200, or does it have to be?
Oh, you like switch these around? Nope, the same answer. Yep. All right, let me give you guys one, and then I'll give you your homework.
Oh, good. We went 30 minutes.
Number 1 on try these. Number 1.
Try these, not
The 5 tickets.
Yep, 5 tickets sell for. How many tickets can be bought for?
Do we have to get a certain amount of people to get it right, or do we just go?
If you get it right, you get to do your homework.
Oh, okay. Ooh, okay.
It's a one-on-one on one-on-one on one-on-one on one-on-one on one. Know which problem I'm doing, boys?
Yes.
All right, go ahead and get it done. I'll give you a time limit of 2 minutes. So begin.
Mister, that's not enough. We need what now? Number 1.
So first set up a proportion and see what numbers go where, and then don't forget your correct
Can we
units.
do any, like, if we don't know, can we do any letter? No.
You can, oh yeah, you can do whatever you want.
Z.
You may even do an E.
Call me number.
Said exactly. Oh, that's right. Your name is Elliot. Wow.
Are these the numbers that we're gonna be dealing with in homework?
Not too many of those harder ones, but it is a tough one right now.
Is it?
You will get a whole number answer. It will not be a decimal number. So if you get a decimal number answer, it is not correct.
Oh, Mr. I got you.
Well, don't say that, Will. Well, he is not your buddy. He's like,
You think I knew this one?
I think I got it right.
All right, I can come by.
No. I don't understand. I don't understand.
Okay, listen carefully. I'll give you a little, if you're kind of stuck, your proportion could have been 5 over 3250. Oops, 3250 equals x over, or any variable over 7150. Okay, so did anyone not get this proportion and write something else? Because there is another way to write it. Yeah, did these two flip and those two flip?
Yeah.
That's allowed. That is allowed. And guys, I'm going to give you, this is, if you really understand proportions, you realize you can actually write it in two other ways, not just by flipping these two. You can actually flip others. But I will not reveal that because I'm not going to throw anyone off. Okay. All right, who can tell me what 5 times 71.5 is? Jack. Jack.
3,575.
So 3575. How many of you got that? Okay. All right. And then I get 32.5 times x, which is 32.5x.
You have to put a zero because you're dealing with money, right? Yeah.
Oh, right here?
To the 5.
Oh, okay. Listen, when you're working with this, it is money, but you don't have to put that decimal and the dollar sign and all that until the end. You can leave it like that. I leave it like that. I think this is, the decimal would have been right there technically, I think.
Yeah, I put a 0 after that.
Yeah, you could, but you don't have to. And then, say it again. There should be a decimal point here.
No, you just didn't add. Oh, is that all you have to add 0?
no, I did.
He is correct.
Why did it 71 times?
Wait, I think I messed up somehow, but still got it.
That's the answer.
It's all right. No. Listen up. Listen up. I got 5 times 71.5 is 357.5.
Oh, wait.
I have that decimal bonus right there.
Yeah, that's right.
So we converted it, but you still divide by 32.5, and you should get. Can I give him the homework and let me check it out?
No, I did it right. Tucker didn't put any tickets. Tucker didn't put the unit.
I don't mind waiting. Oh, I think they're singing for more homework.
No, we're singing about Jesus.
Yeah, for more homework.
Oh, Jesus?
I would end your conversation. I would end that. And then, yeah, put that away, please. Thank you. Your homework is going to be 2 through, I'm going to add in 12. 12 is a little bit tougher, but I'll give you it as a bonus.
So we don't really have to do 12.
Do it.
Oh, but you said it was a bonus.
It's a bonus, but I don't, doesn't mean I don't want you to try it. I need you to try it.
Even. Just kidding. I'm kidding.
All right, goodbye, Swivel.